Section 6.2. This section, we are introducing a new formula. If you want to look for the z, is x minus mean divided by standard deviation, or if we are looking for x, then we use this formula. Now, we understand in the previous section that there is a normal distribution for standard curve. The standard curve is the one that has mean of population 0 and the standard deviation is 1. In that case, the horizontal axis is the z, and the mean, which we are using the z value here, is equal to 0. And you understand that the total area under the curve is always 1. And since this is a symmetric, this vertical line is split into two equal pieces, and each is 50% or 0.5. So this is for a standard curve. When special case, standard deviation is 1 and mean is 0. But what if we deal with the curve with a different standard deviation than the mean? Like this one, mean is 69 and the standard deviation is 2.8. So this one, mean, which is in the center, is 69 and the standard deviation is 2.8. Or the other curve, that curve, the mean is 63.6 and the standard deviation 2.5. So based on different values for mean and standard deviation, you end up having different curve. But all the tables and statistics are designed based on a standard curve, means based on the curve that has this requirement. So if you have a curve, or if you have a problem that mean and standard deviations are not same value, means standard deviation 1 and means we have to do the conversions from this type of curve to the standard one. And for that, we are using the formula, and this formula convert x to z. This type of curve, their horizontal axis is the x, is not a z anymore. So here you see that for conversions from the non-standard, which is the x, to the standard, which is the z, this is the formula to use. Example, let's say in these problems, height of the men are normally distributed with the mean of 68.6 and a standard deviation of 2.8. We want to calculate percentage of the men who are taller than 72E. So we want to calculate probability of x greater than 72. So what we can do, first we have to convert x to z in order to use the z table. And for that calculations, I have that here. So first, and the formula, whether you have a population and the samples, the formula are almost the same. It's just this means mean of population, this mean of sample. This symbol means mean of population, this symbol means mean of sample. So let's say I want to calculate probability of x greater than 72. I have to do the conversion here. When we do the conversions, in the formula, we already have mean and the standard deviation of population, x is 72. By using the conversion, now I find this value of z. So instead of saying x is greater than 72, we want to calculate probability of z is greater than 1.21. So in that case, we could go to the z table and find the probability. Or if you want to use the calculator, on the calculator you put normal CDF and then z1 comma z2, which in this case would be 121, and since it's go all the way to the right, you could just put a large number like 10. However, If you use a calculator, then you don't even have to do the conversion of x to z. Calculator would do it for you. So if you want to use a calculator for normal CDF, if you already know Z1 and Z2, then you just use this formula. If not, then you need to let the calculator know that mean and standard deviations are not 0 and 1 anymore. You have to give it to the calculator. Like in this problem, x is 72. So we want to go all the way from 72 to the end. Since we don't know what the end is, you use a very large number, like 1,000. So this is an arbitrary number. Mean is given, mean of population and standard deviation are given in the problem. So when you input all this information, you find the probability or you find the area. So again, by using this formula, you don't have to do the conversion to the z or use the table. Like in these problems, they want to calculate probability of greater than 64. So in that case, they show the conversions. They show the conversion between 77 and 64. And when you find Z1 and Z2, then they have to go through the calculator. But again, since you already know X1 and X2, you could use the calculator. You don't have to go through all these calculations. I have the same example here. We want to calculate probability of X between 77 and 64. Mean and standard deviations are given. Between 64 and 77, you either have to convert each to the Z1 and Z2, and then either through the table or through the calculator find it, or you don't have to do any conversion. So you could just go straight to the calculator and put X1, X2, mean and standard deviation for normal CDF, because X1 and X2 are already given to you. And mean of population and standard deviation of populations are given. So if you input those numbers into the calculator on normal CDF, then you find the answers rather than going through all these calculations. So X1 and X2 are both ends, means if I want to calculate this area, I need to know the lower bound and upper bound, or lower point and upper point, because we are trying to find area of these sections. Here again, I'll show you how to use it. You could either use X1, X2, mean and standard deviations, or you could just do the conversion first and then do Z1 and Z2. Remember, Z1 and Z2, by default, then the mean is 0 and the standard deviation is 1. Again, here in the example in the text, here the area is given and they want us to find the x. Is opposite of the other problems, means we need to find the x by having 0.95. So in that case, if you want to use your calculator, first of all, from the formula, the value of z is, if you get inverse norm, you know, for area. So if I put inverse norm and then put the area, the calculator would give me the value of z. So when you find the value of z, you put it into this equation to find your x value. So how do I find the z here? To find the z, remember on your calculator, you put inverse norm, then you put the area, and by doing that, when you enter, the calculator would give you the z, which is 1.645. And then you could use that in the formula to find the x. Why? Because the standard deviation of population and mean of population both are given in the problem. So if I cross multiply it, that gives me the x value. Find 95% percentile. 95% percentile means the area is 0.95. Find the x. How do I find the x when the area is 0.95? Again, you could either go to the table, find the area and read the z, or you could just go to second verse inverse norm, put the area, calculator give you the z value. When you have the z value, you could put it back here in the equation, cross multiplication, that give you the x value. So this is explanation of these problems. So area is 0.95, we want to find the x. So when area is given, through the inverse norm, you find the z. You have the z, you put it into these equations to find the x. Again, example 4. Example 4, it's you have a curve with two tails. When you have two tails, both tails are equal. Therefore, the z value is the same value with a positive or negative, because one is on the right side, the other one is on the left side. So when you have a problem with two tails, when you have a curve with two tails, these two tails are always equal. It means they have equal area. So when you find a z for one, all we need to do is use it for the other one with a negative if it's on the left side. So here is 5%. So if I get inverse norm would give me this number. So if you put inverse norm here, and put 5%, then the z value is given. Calculator would give you the z value. When you have the z value, you could put it as a positive for this one. So these two border points are 1.645 and minus 1.65. And since we already know the mean and standard deviation, you could cross multiply and find the x for each of these. You could find the x. You see, one of them has negative this area, give you the x. The x for this point is that. X for this point is that one. This example, we want to find the area between x133 and 79. Again, we are using the formula. If we give you the area, and this is another way to do it, for the inverse norm, if you know the area, you mean and standard deviations, that give you the value of x. So if the area is given and we ask you to find the x, in this example, area probability, if x is unknown but you know the area, that would be area, mean, and standard deviation. That give you the x value for that point. So basically, we are using two formula in this section. One is second verse normal CDF, if you have the value of x1 and x2. The other one is if you have the area and you want to find the x or the z, you use inverse norm. The z score in the formula is unitless. There is no unit for z. So this one, they want you to calculate this area. Okay, so x is 1 of 5. Mean and standard deviations are given in the problems. That give you the z value. And then second by normal CDF for the upper one, you put that number. For lower, you put -5 here, -5 somewhere here. That give you the area. Or you could just do second verse normal CDF put minus 1,000 and 105. That means if we ask you to find when x is 105, if you want you to find this area, you could put a very large negative number here. Let's say minus 1. This is an arbitrary number. So you have both ends. One end is minus 1,000. The other end is positive 105. Mean is 100. Standard deviation 15 given the problem. That gives you this area, which is the probability. Probability would be this one. So we don't really need to use this table anymore if you know how to use the calculator. These tables are given in case you need to use the tables. That one, probability is this shaded area. One end is 90, the other one is 150. Again, we don't have to use the table. Area is given, they ask us to find the x. What you could do from the inverse norm, you put the area, that gives you the z value. So z is 0.67. Then you're using the z in the formula. Mean and standard deviation are given in the problem with cross multiplication. That give you the value of x. So the area is 0.75. Area is given. That helps us to find the z. And then through the formula, since we know mean and standard deviation, that give us the x value. They're looking for the x value. Again, these problems, they want us to calculate this area. It's 138.6. On the right side, just use very large number like 1,000. It's an arbitrary number. That give us the probability, or that give us the area here, shaded. So from problem 6 or 7, 8, the formula is here. Again, they want us to calculate the x. This area is given in the problem is 0.99. Since this area is given, then you find you have the mean, you have a standard deviation. These are all mean of population standard deviation in the problems are given. That give us the value of x, which is 16.7. Same thing here. Area is given is 0.25. Mean and standard deviation are given. That give you the value of x. Number 8, we want to calculate this red area. Each end is given. So that would be 0.0243, or if multiplied by 100, is 2.43%. Number 9. Number 9, I show you the solution here on this page. So the answer for number 9 for the multiple choice is A. For the second also is A is the correct answer. They all are very similar. So the area is 0.95 is given. They ask us to find the x. On this problem, they ask us to find when x is greater than 309. If x is greater than 309, you need both ends if you want to use the formula. Lower is 309. What about the higher? Remember, you use a very large number here, like 1,000. So this is an arbitrary number. Mean and the standard deviation are given the problem. That give you the value or the shaded area. That give you this area. which is a probability. So probability of x greater than 2 or 9 means find this area, and this area is a probability, which is 0.032. And this is for the last problems. This problem is kind of different. It's kind of related to what we learned before. That what is the IQR was Q3 minus Q1. And then for each of this, we calculate the z-score. And then we subtract it, upper limit, lower limit. This is just for purpose of the homework, but it's really related to the past problems. Okay.